You are looking at the most Earth-like world ever found, and almost everything about that sentence is a lie. It has clouds, it has wind, it has rivers that carve valleys, and rain that falls from a sky thick enough to walk through. It has shorelines, it has seasons. From far enough away, you could mistake it for home, but for decades, you couldn't look at it at all. A veil of orange haze wrapped this world so completely that our most powerful eyes saw only a smudge, a blurred amber marble orbiting Saturn, keeping its surface a secret. And then, in the winter of 2022, humanity pointed a brand new kind of eye at it. The James Webb Space Telescope looked straight through the haze and caught Titan doing something no one expected to see. It didn't find a dead, frozen rock. It found something that was still happening, still moving, still becoming. And once you understand what that something is, the silence of this world stops feeling peaceful. It starts to feel like a clock. Let's start with what Titan is. It is the largest moon of Saturn and the second largest moon in the entire solar system, bigger than the planet Mercury. But size isn't what makes it strange. What makes it strange is its air. Titan is the only moon in the solar system with a thick atmosphere, not a thin wisp like Mars. A real one, denser than the air you are breathing right now, pressing down harder than Earth's own sky. It is made mostly of nitrogen, just like ours. And inside that nitrogen, something familiar is happening. There are clouds up there. They gather, they drift, they release rain that falls all the way to the ground and pools into rivers, into lakes, into seas large enough to swallow the Great Lakes of North America whole. Stand on the surface and you would see weather, real weather, a landscape shaped by liquid falling from the sky over millions of years. Deltas, channels, coastlines. It is the only place we have ever found, besides Earth itself, where liquid falls from the clouds and collects on solid ground. And here is where the familiarity breaks, because none of that liquid is water. It is methane, the same gas that hisses out of your kitchen stove. On Titan, it is so cold, nearly minus 180 degrees Celsius, that methane behaves the way water does on Earth. It evaporates, it clouds, it rains down as cold, oily droplets onto a frozen world where the rock beneath your feet is water ice, hardened until it's as solid as granite. A second Earth, running on the wrong chemistry, at the wrong temperature. And for 13 years, we watched it through a single fading pair of eyes, never quite seeing the one thing that mattered most. Almost everything we know about Titan came from one mission, Cassini, the spacecraft that orbited Saturn for 13 years and dropped a small probe called Huygens through Titan's haze in 2005, the only landing humanity has ever made in the outer solar system. For over a decade, Cassini mapped Titan's seas, traced its rivers, and watched its weather from above. And then, in 2017, it was over. Out of fuel, Cassini was deliberately steered into Saturn and destroyed to protect the moons it had spent so long studying. It left behind a problem. Titan's year is long. A single trip around the sun takes nearly 30 Earth years, which means its seasons last for years at a time. And for almost all of Cassini's mission, Titan's northern hemisphere, the half of the world where nearly all of those methane seas are pooled, was locked in the dim half-light of winter and early spring. The North was just waking up when Cassini died. Its summer, the season when those seas should be warming, evaporating, driving the weather hardest, had barely begun. No spacecraft was there to watch it. So when the James Webb Space Telescope turned towards Saturn in November of 2022, and again in July of 2023, it wasn't just taking pretty pictures. Working alongside the Keck Observatory in Hawaii, it was aiming its infrared eyes at a season of Titan that no close instrument had ever properly seen, and at the exact region where its seas are concentrated. The question going in was simple. Does Titan's weather actually do anything up there? The answer it sent back changed the question entirely. It stopped being about whether Titan still has weather, and became about what that weather is quietly doing to the chemistry of the entire world. Here is the first thing Webb saw. In the mid and high latitudes of Titan's northern hemisphere, right over the seas, there were clouds. That alone wasn't a shock. We'd seen Titan's clouds before, but these clouds were doing something. Over a span of days, Webb and Keck watched them climb. They rose to higher and higher altitudes, lifting through the atmosphere in front of our eyes. To you, that might sound minor. To a scientist, it was electric, because rising clouds are the fingerprint of convection, the same engine that builds thunderstorms on Earth. Warm air lifts, carries moisture upward, cools, and lets it fall again. It is the heartbeat of a living weather system, and it had never been confirmed in Titan's northern hemisphere until that moment. Think about what that means. Titan is not a frozen photograph. It is not a dead world holding its breath. It is breathing. The methane seas evaporate. The vapor rises. It gathers into clouds, climbs, and eventually returns as rain to refill the very seas it came from. A complete active turning cycle. 1.5 billion kilometers from the sun, in the cold and the dark, entirely without our star's warmth to drive it the way it drives ours. And the sky it happens in is enormous. Because Titan's gravity is only about 1/7 of Earth's, its atmosphere puffs outward. The layer where weather happens rises to around 45 kilometers, nearly 4 times deeper than Earth's. A vast, hazy, churning ocean of air, with storms climbing through it. For a moment, hold on to that image. A second living world. Rain and clouds and seas and seasons, all of it working, all of it real, because it was the next thing Webb found, not in the clouds, but in the air between them, that turned all of that wonder into something far more unsettling. When Webb broke Titan's atmosphere down into its individual wavelengths of light, it was reading the air like a barcode, pulling out the signature of every molecule floating in it. And one of those signatures had never been seen on Titan before. It's called the methyl radical. Its formula is simple. 1 carbon atom, 3 hydrogens, CH3. A fragment, a broken piece of methane, caught in the middle of becoming something else. Here is why that fragment matters. On Titan, sunlight and charged particles streaming off Saturn are constantly smashing methane molecules apart. The pieces don't just float away, they recombine. They link up into longer, heavier, more complex molecules, the building blocks of organic chemistry, the same family of carbon-based molecules that, on the early Earth, eventually led to life. For decades, we could see the starting ingredients in Titan's air, the raw methane, and we could see some of the finished products, the heavy organic haze, but we had never caught the middle, the reaction itself, the moment of transformation, as one of the scientists put it. Until now, we'd only ever seen the flour and the sugar, and then the finished, iced cake. With Webb, for the first time, we are watching the cake actually rising in the oven. Sit with that. On a moon of Saturn, in a sky of methane, the chemistry that precedes life is happening right now. Not frozen in the past, not theorized on a whiteboard, but unfolding in real time, caught in the act by a telescope built by a species on another world. This is not life. Let's be precise about that. Webb did not find Titan crawling with anything, but it found the recipe, being followed, step by step, in the present tense. So why would a scientist look at that, the building blocks of life assembling themselves on another world, and feel something closer to grief than to hope? The answer was hidden in a third number, and that number is where the wonder ends. Every time Titan breaks a methane molecule apart, it frees hydrogen. And that hydrogen is light. Light enough that, little by little, it drifts up through the atmosphere and escapes into space. It does not come back, which means Titan is losing the very ingredient that makes it what it is. The methane that fills its sky, fills its seas, and feeds its strange chemistry is being slowly, permanently used up. And as far as we can tell, there is no obvious source replacing it fast enough to keep pace. Unless something deep inside Titan is refilling that supply, the clouds will thin, the rain will stop, the seas will dry, the whole magnificent cycle will wind down and go quiet. Now, you have heard this story before. You just didn't know it was the same story. It happened to Mars. Mars was once a world with water, rivers, lakes, maybe even an ocean. And then its molecules began to break apart. Its hydrogen bled away into space. And over hundreds of millions of years, that blue world became the red, silent desert we know today. A planet that died slowly, by losing its sky one atom at a time. Titan may be walking the same road, same exit, different fuel. So look again at what Webb actually captured. Not a world being born. Possibly a world in the last brief spring of a chemistry that is already running out. The clouds, the seas, the recipe for life rising in the oven, all of it may be the final act, not the first. Webb didn't catch Titan waking up. It may have caught Titan breathing out. And this is the part that should keep you up at night. Consider the timing. It took our species 4 billion years to appear, a few thousand to build civilization, a few decades to learn how to fold a mirror of gold-coated metal, fly at 1 million kilometers from Earth, and teach it to read the chemistry of a moon we will likely never set foot on. We finished that telescope. We pointed it at Titan. And we did it during the exact stretch of cosmic time when Titan's chemistry is still active, still visible, still happening. A few million years too early, and there might have been nothing yet to see. A few million years too late, and the seas might already be gone. The sky gone still, the recipe abandoned mid-sentence. We arrived in the window, the narrow flickering window when this world has something to show us. We won't have to rely on telescopes forever. A NASA mission called Dragonfly, a nuclear-powered drone, a rotorcraft built to fly through Titan's thick air, is on its way to land there in the 2030s and hunt through that chemistry up close. For the first time, we will study those building blocks where they form. But Webb has already handed us the warning. There is a clock running on Titan, and it is running backward. So go back to where you started, to that amber marble, wrapped in haze, hiding its surface behind a veil. You know now what's underneath. Rain that isn't water. Seas that shouldn't exist. Storms climbing through a sky 4 times too deep. And in the air between the clouds, the quiet chemistry that once, on one world, became us. Life needs time, and Titan's clock is winding down. So when you look at that orange world now, you have to ask what you are actually seeing. A cradle or a grave. The first chapter of something, or the last page. Did we arrive too early to watch life begin out there, or too late to watch it bloom? Titan has been waiting 4 billion years for someone to look closely. The unsettling part isn't that we finally did. It's that we may have looked at exactly the wrong moment, or the only one we were ever going to get.